let's talk about extending our base 10 number system beyond or to the right of the decimal point. One of the reasons decimals feel so much quote unquote easier to work with is because they follow these same, and I put it, in these quotes again, rules as whole numbers. And what that means is that we really want to pay attention. And this is why, understanding place value and our number system is so important, right? So we've been working with whole numbers, right? We go 10 times to the left, 10 ones make a 10, 10 times to the left, 10 tens make 100, 10 times to the left again, right? Each place value is this idea of bundling, regrouping, bundling or regrouping in sets of tens. And we see that each place value, right, depending on where the number is, right, the location of the number tells us how much it's worth. So that's where you get this, these powers. Each place value are these powers of 10. And so this same pattern, if we look now to the going to the right, we divide, not add, we divide by 10 as we move to the right, divide by 10, divide by 10. And actually this same pattern continues. 1 divided by 10 is now 1/10. 1/10, or, right? Or actually, I think we were writing it as, oh, hold on. Sorry, 1/10, which is again 1/10, or 10 to the negative 1, right? Notice the what's happening with our exponents. Take away an exponent, take away an exponent, take away an exponent, right? 3, 2, 1, 0, the next place value or the next number after that pattern, right, would be this -1. And now that continues. Keep dividing, right? Divide as we moved, divide by 10. Sorry, it's hard to kind of see on there. As we move to the right, divide by 10. And so this becomes 1/100, or 1/10 times 10, right? We see hundreds are 10 times 10. Let me see, right here, where hundredths are 10 times 10, but in the denominator, right? Now we're to the right of the decimal place. Or what we can see then is that would be 10 to the -2, because we continue this pattern with our exponents. Same thing with thousandths, 1/1000, or 1/10 times 10 times 10, or 10 to the -3. Keep dividing by 10 again. As we move to the right, divide by 10, right? Put another power of 10 in the denominator, and we get 1/10,000, or 10 times 10 times 10 times 10, right? 10 to the 4th power, but in the denominator, which is 10 to the -4th. Or you can even think about it, 1/10 to the 4th, 1/10 to the 3rd, 1/10 squared, 1/, right, 10 to the 1st power. Oh, that's a 1 there. So this idea of, so keep going. So here, right, to go from thousandths to hundredths, it's just times 10. Hundredths to tenths, right, is 10 times bigger. And so this idea of bundling in sets of 10, still the same exact pattern, whether you're to the left of the decimal point with whole numbers or to the right of the decimal point with decimals, right, with rational numbers. Now, these are the exact same rules of this bundling in sets of 10. And that is so important, as we saw when we're adding and subtracting numbers, or basically for any of the operations, right? So when we're thinking about, maybe 17 plus 24, we can think about a 1 7/10 plus 2 4/10 in the exact same way, right? Because 7/10 plus 4/10, I'll put like a squiggly line. They're think about in same way, or maybe, think about is the exact same procedures, right? What we do when the 7 plus 4 is in the ones versus the 7 and the 4 in the tenths, we're still going to regroup in that set of 10. And so that's what it means by, right, follow these same exact rules as whole numbers. Because of this base 10 number system, we regroup in sets of 10. So whether they are tenths, hundredths, thousandths, right, these teeny tiny pieces to the right of the decimal place, or they get big and big and big to the left of the decimal place. It's the exact same rules. And so what we want to see is that we can use these same exact representations because of this regrouping in sets of 10, right? This factor of 10 times bigger, 10 times bigger, right? 10 of these little guys fill up this rod. 10 of these rods then make up this flat. And this is why we're calling them, right, rods and flats and the unit cubes, because now this same exact pattern that we just saw with the whole numbers, right, or 1/10 divide by 10, or 1/10, maybe I'll say previous digit, right? 1/10 of the previous, 1/10 of the place value to the left, the previous digit, is this same exact relationship. So now what we can see, I'll clear this. Now, if we move the flat to be the ones, what would be, right, 1/10 of a 1, right, to move to the tenths place. And then, right, what did you think, right? What is 1/10 of the flat? Did you guess it? Yeah, the rod. And now likewise, what is 1/10? Divide by 10, take these 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want one of them, right? Divide this by 10. We only want one. So 100th then would be the unit cube. And so these base 10 blocks are so important because they have this relationship of magnitude, right? 10 of these fit in, or maybe how, because we'll go to the right? 10 of these, right, times 10. Sorry, that didn't work. Times 10 of the unit cubes make up the rod. Same thing, times 10, right? 10 of the rods make up the flat. So if we call the flat a 1, the rod then becomes the tenths, then the unit cube, right? Or we can even think go all the way this way, right? Times 100, we're jumping 2 place values. A 1, 2, right? 100 of these fit in here. So this is, right, 1/100th of the flat. And so this is where we can really use the base 10 blocks to show this magnitude and this idea of place value of 10 times bigger, 10 times smaller, and how this same exact pattern transfers from whole numbers into decimals. And so let's try this one more time. So what if the flat was now a 10th? What would 100th look like if I was going to divide this by 10, right? What's 1/10 of this rod? Of this flat? There you go. I just gave it away, right? The rod. Likewise, what's 1/10, or divide this whole rod into 10 equal pieces? You got it, right? The cube. Now here's the challenge. So what would the ones look like, right? We know it's 10 times bigger. It's in here. Sorry, I was seeing yep, I didn't have in this representation, right? In the blue ones, right? It would be 10 of these, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, it doesn't fit all the way in there, but right, it'd be 10 of these flats. And the way we see those 10 flats is in that big, huge cube. And then what would then tens be? Yeah, 10 of these 3D huge cubes, right? All stacked up into this rod, it would look like, right, 10 of the big, 3D cubes would then be all stacked up to create tens. And then we could see how teeny, teeny, tiny, right? This little guy, we would need, right, 1,000th or 1,000 of these to make one, or the whole, right? This would, and that's exactly what this is saying. And this is how we see that with this representation in the base 10 blocks. And so this idea of, right, these same rules, right, and that those rules are just regrouping, bundling in sets of 10, or if you'd like to think about it as each place value is either to the left is 10 times bigger and to the right is 1/10 the size or 10 times smaller. And those are the rules that we're talking about when we're working with decimals, which is exactly the same as when we're working with whole numbers. And that's why decimals kind of quote unquote feel easier, because it's these same exact pattern that we had with whole numbers.